So let us now discuss a very important structure that is often used to give bridges its stability. Now, before we discuss what this structure is, let's look at the following situation. Let's suppose we have two rooftop edges and a gap is separating our two edges. And let's suppose that in order to connect our two edges, we simply take a wooden beam and place that wooden beam across our gap to connect our two edges. Now, why is this not a very good idea? Well, for one thing, if we have a very large mass moving across that beam, that mass will create a force, and that force will be concentrated. In other words, that force will act to deform the beam, and that deformation of the beam will create shear stress. And not only that, that beam will also experience tensile as well as compressive stresses. So the stress level in that beam when a mass is moving across the beam will be very high. And if the mass is high enough, the stress will be high. And if that stress level will reach the ultimate strength of that bridge, of that beam can fracture, it can break. So it's very unsafe. Now, what is one thing that we can do to this beam to give it more stability, to give it more structure? Well, we can add something known as a truss. A truss is essentially a system, it's a framework of rods, also called struts, joined together at their ends by pins, in which the rods, our struts, are always arranged in triangles. Now, the reason we use triangles is because triangles are relatively stable shapes. They will not deform very easily when a force acts on those triangles, in the same way that rectangles will deform very easily into parallelograms under shear stress. Now, trusses are used to support beams. In other words, we can use the following beam in this example, and now we add a truss. And this is our truss. This is our framework of struts. So each one of these rods is known as a strut, and these points are our pins. They're positions that connect our two or more rods together. So these points are also known as joints because they join two rods together. Now, usually when we're solving examples that involve trusses, we make the following assumption. We assume that the forces that are acting at the joints, at the pins, point along our strut, along the length of the strut. So what we're basically assuming is that each strut is assumed to be massless. That is, the mass of the load that is resting on the beam is much higher than the actual mass of that truss. So we can neglect the mass of that truss. And if we neglect the mass of that truss, there are two types of forces that can act on our strut. We have tensile forces and compressive forces. So whenever we have tensile forces, that simply means that the forces are acting along the length of the rod and point outward. If we're talking about compressive forces acting on our rod, well then, these forces point along and point inward into our strut. Now, what is actually taking place in a realistic situation? Well, let's look at diagram 3. Real struts have mass, so forces at the joints do not point exactly along the strut. And that's because we have the force of gravity acting at the center of mass. Notice that the reason that trusses work is because each strut is assumed to be in static equilibrium. In other words, these struts do not move. And that means the sum of the forces as well as the sum of the torques acting on each strut is assumed to be 0. And so if we sum up the forces and the torques acting on point 1 or on diagram 1, diagram 2, we see that our forces and torques will sum up to 0. And in the same way here, we can also add up all the forces and torques acting on our rod on the strut, and these forces and torques will sum up to 0. Now, why is it that these forces don't act at an angle when we assume the struts to be massless? Well, that's because if that was the case, if these forces did not point along the length of the strut and they pointed at some angle, notice that this would create a torque. But because the struts are assumed to be in static equilibrium, we know that this cannot be true, because whenever an object is in static equilibrium, that object's net torque, the sum of the torques, has to sum up to 0. And if this was the case, then the torque would not be 0 because the object would rotate. So once again, what exactly is a truss? A truss is simply a system, a network of rods that gives stability to our beam because it distributes the force along these joints.